All right, well, thank you everyone for being here. I think most of the internet was down this morning, but seeing as I just had twins 4 weeks ago, it's given a new meaning to the word uptime. Thank you for laughing at that. I appreciate it. Last minute addition. I'm just looking around, and if you would have told me 4 years ago when we started LiveKit that there'd be all these people here to learn about what we're up to, I would not have believed you. See, LiveKit came from very humble beginnings. It originally wasn't even meant to be a company. We started during a very different time in the world. This was a time where you couldn't leave your house. The only way for you to connect with other people was over the internet. You used apps like Google Meet, Discord, and Zoom. And the reason you used those applications in particular was because they were designed for streaming audio and video in real time anywhere in the world. Most of the internet was not designed for this purpose. HTTP, you probably all know as developers, stands for Hypertext Transfer Protocol. Hypertext, not hypervoice, not hypervideo, hypertext. It was built for transferring documents over a network. It turns out that there was another protocol that had been operating in relative obscurity up until that point. The same protocol that Zoom and Google Meet and Discord are built on top of, called WebRTC. Except those applications that we used during the pandemic, they had spent 10 years building infrastructure around this protocol that allowed it to scale. And so back during the pandemic, David and I, we were working on an idea, an app idea, and we needed to stream audio and video at scale. Except we didn't have that infrastructure that those other folks did. So we started to work on our own infrastructure to make it possible. And while the app idea didn't go anywhere, we ended up rolling out that infrastructure as an open source project called LiveKit that would make it so any developer could build audio and video applications that scaled. Very quickly, LiveKit became a really popular project on GitHub for doing audio and video streaming. And fast forward to now, I'm really proud to say that it is now the most popular WebRTC project on GitHub. And almost in the first week since that initial release, we started to have large companies taking the software, deploying it, and using it, like Reddit and Oracle and Spotify and X. And when we had conversations with them, we were asking them, like, why? It's just 3 people working on this open source project. And what they told us was that nobody could deliver at the API level what Zoom can deliver at the application layer. Nobody could deliver WebRTC with 5 nines of reliability, the lowest latency possible through an edge network, and scale to any shape of user traffic, whether that's millions of people in a single session together or millions and millions of sessions taking place around the world. And so we saw an opportunity to sustainably work on LiveKit for decades to come by creating a company around it, raising a seed round, and building what we would call LiveKit Cloud, a globally distributed edge network optimized for those 3 core pillars of infrastructure: reliability, scale, and latency. We worked on it for about 2 years before putting out the first release of it at the end of 2022. And at the end of 2022, this other amazing piece of technology came out called ChatGPT. And I was using it, like I'm sure you all were, and I was stunned at how it felt to interact with this application. It felt like I was texting with a human being, with a friend. And so I thought, well, what if we took WebRTC, what LiveKit does, and we pair it with ChatGPT, and instead of a computer that you could text with, what if we could create a computer you could talk to? So we did that. We built a demo called Kit, after Knight Rider, and we wrote a blog post about how we did it. And when we posted it to Twitter, as it was called at the time, and just sat there waiting to go viral, we were sure that we were going viral. That didn't happen. I have yet to go viral on Twitter, or on X, I should say now. But 5 months later, OpenAI found the demo, read the blog post, and decided to build ChatGPT Voice as we know it today on top of LiveKit Cloud. And it was this moment that was the catalyst, not just for the voice AI industry that we find ourselves in today, but for a coming paradigm shift in how you are going to interact with the computer. Computers are going to become more human to use. They're going to feel more human to use than ever before. And they are going to, the keyboard and the mouse are going to be replaced by the camera and the microphone. And computers will be able to perceive the world the way that we do. And for LiveKit, Ben Thompson, the author of Trajectory, he calls OpenAI the accidental consumer company. I call LiveKit the accidental AI company. This moment really catalyzed a shift for us as a company and as a product and as a team. If OpenAI and Anthropic and xAI and Gemini, the foundational model companies, were going to build the brain, LiveKit had an opportunity to build the nervous system. All the infrastructure around that brain that gave your application as a developer the ability to do something it's never been able to do before, and that is to see, hear, speak, and interact with you. And so this new journey that we were embarking on as an AI infrastructure company, the way it started was through the LiveKit Agents framework. We did a lot of work with OpenAI with voice mode. And what we ended up doing was taking that work and turning it into a general purpose framework that allowed every other developer to build similar types of applications. And that framework allowed you to do something else that was pretty unique at the time, which was you could write a server program that could use WebRTC on the back end. So you could consume audio and video streaming in, and you could generate audio and video to stream back out anywhere in the world. It also included custom models that we trained in-house to handle conversational dynamics unique to voice AI. So interruption handling and end-of-turn detection. So being able to give the model the ability to understand when you are done sharing your thoughts with it and when it can start to speak to you. The framework also included the ability to take complex workflows that are too complex to put into a single system prompt and model those out in software. It gives you full programmatic ability to break down these problems, create multiple agents to handle a task, and then hand off seamlessly between those agents. But most importantly, I think, the agents framework had or came with a vibrant ecosystem of partner integrations. So with a single line of code, you could integrate any TTS, STT, LLM, or even video avatar model. And in the time since we put out the agents framework, the growth of LiveKit as a platform has been amazing. The framework itself is downloaded over 1.5 million times every single month. And on the runtime side, so when you build that agent and you run it on our infrastructure, we're doing over 3 billion sessions every year on the platform. That's millions and millions of sessions every day, even just right now, this very moment. And we have an ecosystem, or a community rather, of developers that have also formed around LiveKit and are building with it. 200,000 developers, which includes over 10% of the Fortune 500. And what they're building are voice agents for all sorts of different things. Voice agents for freight and logistics planning, for patient intake at a hospital and clinics, for an educational assistant that helps you learn material, an AI therapist that allows you to practice regular mental health. Customer support is obviously a very popular one that developers build on top of LiveKit as well, but maybe the one that's probably closest to my heart is LiveKit powers over 25% of 911 emergency in the United States. And so we have agents that sit in a dispatch center and help the human dispatch agent triage issues as they come in and provide situational awareness to fire, emergency response, and medical. And those agents, well, LiveKit, facilitated through these 911 calls, saves a person's life every single week, at least one person's life every single week. So it's an incredible set of use cases that developers have built. And while the growth has been amazing, and there's a new voice AI use case that is shipping and scaling every single day on LiveKit, we've also learned over the last 2 years that it's still hard to build these kinds of applications. You see, voice AI applications are completely different from traditional web software. They're real-time, they're conversational, and they're stateful. They're almost the exact opposite of a web application. And so to build these kinds of things, you still have to do a lot of infrastructure work yourself as the end application developer to get these things to scale. And the way we've been thinking about it is, how do we make voice AI apps as easy to build as web applications? And because these applications are completely different, you have to think about it or approach it from the perspective of rethinking the entire application development lifecycle. It starts with build. When you're designing and building your agent, the agents framework that we put out a year and a half ago allows you to have full control through code over that agent that you're building. The next step after you've built that agent, you think you've got the system prompts correct, and it's going to do what you think, is to test that agent and evaluate it. And the issue with this is that the LLM itself is stochastic. Given an input, it's not always going to generate the exact same output. So you can't write a simple assertion to test your application. You have to test your voice application almost similarly to how we evaluate human performance. Humans get high school diplomas and college degrees and have resumes and job interviews. You almost have to test a voice AI in a similar fashion and build a statistical confidence it's going to do the right thing. And so we have a lot of partners in the test and eval space, some of them here today, that deeply integrate with LiveKit and allow you to do that seamlessly. Once you've tested your agent, you feel comfortable about going to production and scaling it and load balancing it, that's another hard problem that's different from traditional web applications. You can't load balance these things like a web app, where you can round robin across a bunch of web servers. Sessions can last for 2 minutes or an hour or half an hour. It all depends. And so deploying and load balancing a voice AI application is more like scaling a multiplayer video game. So earlier this year, we put out agent hosting, or Agents on LiveKit Cloud is the official name. I got you, Jenny. But what it allows you to do is you can take your code for your agent that you've built using our framework, you can push it up, we will actually host it across all of our data centers around the world and manage the entire lifecycle for you. Of course, after you've deployed that agent, it's now running and connecting with users around the world. And we had the WebRTC network that we provided. But very quickly, we followed up with a SIP stack. This allows your agent to be fully omni-channel. So you can write your agent, build that agent one time, and you can deliver it through web, through mobile, through an Apple Vision Pro, and through a telephone. And most recently on the runtime side, we announced the inference gateway. And one problem that we had been hearing from developers running these workloads at scale was that they rely on a myriad of different TTS, LLM, and STT providers. And the providers they rely on are also different in different areas of the world. And there are certain ones that excel at certain languages as well. So it's this high dimensionality space where for a voice agent, what you really care about is end-to-end latency. But you have different points of failure along the way when there are different model providers and they're distributed around the world and running compute in different places, and your user's connecting from a certain spot and your agent is hosted in a certain place. And so it turns out that a lot of the same infrastructure we had built for routing media with as low latency as possible between data centers can be leveraged for routing inference workloads. And so that's the inference gateway. And then the last part of this puzzle here is observability. Once you have your agent running at scale in production, how do you know what it's doing with users? How do you know how they're interacting with it? And then once you understand how they're interacting with it, if you see adversarial examples, how do you take those examples and the learnings from them, pipe that back into your build step, and iterate rapidly on your voice AI app the same way that you would for a traditional web application? And so what we envision is a way to build these kinds of applications in this fashion and rapidly iterate on them such that it feels just like it's felt to build something with Next.js. That's kind of the vision that we're chasing. And so in that vein, we're really excited to announce 3 new additions to the LiveKit platform. They're going to make your agents easier to build, more performant, and more reliable than ever before. And so with that, I'd like to welcome up DZ, my co-founder, to take you through the first one. His name is David, just to... Oh, so sorry.
Thanks. Thanks, Russ. So people call me DZ at the company. So for those of you that don't know or haven't seen my Slack handle, David's my name. So let's talk about building agents. In the last year, we've poured everything that we know about voice AI into the agents framework. The agents framework really takes care of all the hard parts about building voice agents. And we think of them as kind of the undifferentiated parts about building voice AI. Things like real-time voice and video streaming, model orchestration, and even things like function calling, so that you can focus on building what your agent is supposed to do. And where was I? So why code, right? Why like a framework for building agents? Because when you need ultimate flexibility, control, and the ability to hook into any backends or tools, really like nothing beats code. But for somebody who's building agents from scratch, building even a hello world agent can still take a little while. This is because at the end of the day, LiveKit agents is a framework. A framework requires you to read documentation, find examples to run, and even sometimes go into these loops where you spend time to debug. Sorry, blanking a little bit. So how do we actually make this faster, right? The afternoon is not bad, but it's not good enough. So earlier this year, I asked the team, how do we make it so that a user could go from 0 to a production-ready agent in under 10 minutes? And fortunately, the team took up my challenge. And today, I'd like to introduce you to something really cool that we're really proud of, the Agent Builder. The Agent Builder is the fastest way to build voice agents from 0 to production. And with that, my colleague Ben will show you a demo.
Everyone, my name is Ben. I'm the head of developer products at LiveKit, and I'm going to walk you through the Agent Builder. We're going to build an agent together. Well, I'm going to do the building. You're going to watch, but we're going to be participants, and we'll run it, deploy it to production, and see what happens. So over here in my web browser, I've got some tabs ready for you. So this is the LiveKit Agent Builder, and this is in the LiveKit Cloud dashboard. So any project has access to this. You can do this on the free plan. You can do this on the paid plan. This is a simple web browser experience. We've really focused on simplicity here. We know that we have an extremely powerful platform for building and deploying any kind of agent to do any kind of workload in code. And we've really focused here on ease of prototyping and proof of concept to get something that really gives you that wow moment and convinces you or your colleagues or your boss or anyone else to invest in voice AI, which we think is an amazing, I'm going to refresh just because it's been open a little while. I just started this project just before this. I didn't do anything here. This is the defaults. And right here in the thing before I've deployed it, I can talk to it.
Hello. How can I help you today?
Hi, could you tell me a little bit about yourself?
Sure. I'm a voice assistant designed to help you with information, answer questions, and assist with tasks using available tools.
So this is a simple agent that's built. This is pretty much the same as our quick start. If anyone here has worked with LiveKit agents before, you've built an agent just like this. But one of the things that's amazing here is we can now make some quick changes. So I'm going to put the microphone down and type for a second. Actually, can I? OK, so I'm going to make this an agent that can look up a stock price on demand. So I'm going to edit its default system prompt right here in the browser. So far I've edited the system prompt, nothing too crazy here. Let me go and play around with tools. So we can add an HTTP tool to this agent right in the browser. So I actually happen to have one. Over here, we have this amazing stock market API we built. This is not a new product we're launching, but it looks like it because Cursor is pretty amazing at putting out some production-ready stuff pretty quick off a little prompt. This built with GPT-5. So I'm going to take this API, go over here. Okay, so you can see I've just kind of plugged in a basic HTTP API. I'm sure everyone here is familiar with that. And it has one parameter symbol. You can build something much more complicated, but it's already enough typing here for this demo. So I now have an agent, which is a stock market helper, and it's got an HTTP tool, and we're going to see if that works.
Hello, welcome to LiveKit DevDay. How can I assist you with stock prices today?
Hey, could you tell me what the current stock price of NVIDIA is?
The current stock price of NVIDIA is $181.36. Would you like to know about its recent trend or some other stock?
So you can see here that it performed a tool call using the HTTP tool, fetched from the API, it showed up right here in the builder. So I can continue to iterate on this, but for the interest of time, I'm going to go ahead and hang up the preview, and let's take this to production. We love shipping things here at LiveKit. Got a lot of things to ship today. So I'm going to press deploy. Anyone want to guess how quickly it's going to deploy? 1 second. That's probably actually about the closest. Something funny going on with timestamps here. Also spinning up a web front end for it. And maybe it was closer to 20 seconds. There we go. So I'm going to go visit this in the LiveKit Cloud sandbox front end, which I just made for it. So this is now running in production.
Hello, and welcome to LiveKit DevDay. How can I assist you with stock market information today?
And I'm going to hang up there and hand this back to David, who's going to, I think, take us through some other things. But I have now deployed a voice agent into production on top of LiveKit Agent Builder. There's a lot more in here. I'm really excited. Oh, actually, there's one more thing I forgot to share with you. So one thing about the way this is built is we've actually, we really believe in code. We believe strongly that code is the way to take many of these agents into complexity. So this is actually built in code. This actually generates code on the fly in the agent builder. You can actually see if I, for instance, rewrite the prompt, it will update in real time over here in the generated code. This is an actual LiveKit agent. If anyone here has built LiveKit agents, you'll recognize this is the right way to do it. This is a best practices agent. The tool has been statically generated in code, so it's easy to follow. It works exactly the same way as any tool any expert developer would build with LiveKit. And this is what's deployed. It's deployed on top of the SDKs exactly the same way. It runs perfectly. It doesn't mix runtimes with other sorts of agents. It runs in your LiveKit Cloud project. And at any point, you can actually come copy this code or download a zip file containing this and an agentsmd file and a README and everything else you need for a Python project hooked up to our LiveKit Docs MCP server we recently launched. And you can continue to confidently iterate your agent in code when you've outgrown what's possible in the builder with a single system prompt.
All right, thanks, Ben. That was pretty cool. How long did that take? Anybody timed it? I think it's under 10 minutes, right? All right, so next up, we've got telephony. So LiveKit today, every day, handles over 2 million calls in production, and customers are building all sorts of different services, from customer service to sales to even handling 911 calls. So in order to support all of that traffic, we built our own SIP stack from scratch. So this includes features like HD audio, proper DTMF handling, code and worm transfers, and even built-in noise cancellation. Basically, all the stuff that you expect to just work. A typical call would flow something like this, where it would go from the user's device first to the carrier networks, and then it stops, makes a stop at something called a SIP trunk provider, which actually connects the call to LiveKit. And then at that last to your agent, right? So this is not bad. This works today very well, but you can notice that it takes quite a few network hops to get to your agent. So we asked ourselves, how do we simplify this? Well, the first step is pretty simple. If you deploy your agent into LiveKit Cloud, they're running in the exact same data center as the rest of the LiveKit network. So that last hop, you can kind of save right off the bat. But how do we reduce complexity further? Because every network hop that you make adds latency and jitter and stuff like that. And when you're debugging call quality issues, it's just one more variable that you have to eliminate. So can we actually skip the SIP trunk provider? Can we essentially make the call go direct? So today, I'd like to introduce LiveKit phone numbers, our first-party service for telephony. The same call that you're making now can flow from the user to the carrier. Of course, we can't get rid of them. We kind of need them. But then directly into this exact same data center that's terminating call as your agent in the most optimized path possible. So what this means is that latency and jitter goes down and reliability goes up. So this is available today. You can go to your LiveKit dashboard and start to buy a number. We currently support US numbers, both local numbers and toll-free. And outbound calling, along with international expansion, will be coming later. Now, Nishad will come up and show you guys a demo.
All right. Okay, that took a while. All right, so I'm Nishad, and I lead all our telephony-related efforts here at LiveKit. So David kind of told you what we've added. Let me just show you what it involves. So Ben used the same interface, right, to create an agent. Let me take you over to our telephony tab. So if before today, you would have probably just seen two sub-items in the menu here, calls and something else called configuration. And the configuration involved the ability to add inbound and outbound trunks, which were the SIP trunk providers that DZ was talking about, as well as dispatch rules. So what we've done here is sort of change things up, and we've added this new tab called phone numbers. Everything else is kind of like split out. So I'm going to dive in a little bit into the phone numbers experience and show you how easy it is. So let's just look at buy a number here. I'm going to click that, and you have a bunch of phone numbers that show up. Let me choose the 925 area code because I'm from the East Bay, and that's what the area code over there is. Cool, so enter. Yeah, there you go. Let's buy this one and confirm. All right, numbers purchased. And we have in LiveKit a concept called dispatch rules. That's the way you hook up a phone number to an agent. So let me create a new dispatch rule. It's going to say demo, and over here, we need to add that agent that Ben created. So the name of that agent was stock helper. And over here, this was the phone number that we just bought. It's already pre-selected. So I'm going to create that. And all right, cool. A moment of truth is now. So I'm just going to make that call. And it's going to be a bit tricky because I'm going to put in the mic over here. The number was 925-623-0795.
Hello. Welcome to... Hi there. How can I assist you with stock prices today?
Hi, what is the price of Apple?
The current price of Apple stock is $267.44. Would you like to know the price of any other stock?
Not for now. Thank you so much. All right, there you go. That's simple. Like, I'm handing it back to DZ now. Thank you all. All right.
Thanks, Nishad. There we go. Wait. Sorry. Okay, so back to this third product we're launching today. I guess they kind of give it away, so. So the hard part now comes, how do you take it from it works great in a demo that you just saw to it works great for thousands of users in production, every single call that you don't want failures for, right? So that's a hard challenge I think all of us are going to go into. And here's why it's a hard problem. So voice agents are both LLM-driven, and they're multi-turn, and LLM-driven apps are non-deterministic. So it's really hard to predict what happens several turns down the road. And even a mishap early in the conversation can actually manifest itself 5 turns later. And this is really tricky to resolve. Also, when you're shipping it to the real world, real users, they can mumble, there's background noise like in this conference room today, and they're not really the exact behavior you're testing, right? It's hard to simulate all of the different paths that matches the chaos of the real world. So in traditional software, though, we use tools like Datadog or OpenTelemetry for logs and traces. This is how we debug and troubleshoot a real software system. But that doesn't really answer the question that we have in terms of when you're talking about a voice agent, right? So things that you care about are what did the user actually say? Here's what's transcribed, but what did they say? What kind of prompts went into the model for exactly that conversation? And even things like when a conversation does break, where did it break and why did it break? So none of the existing tools are really built for that. So today I'd like to launch a new product that we have. The team's been working super hard on this and we're quite excited about it. It's native observability for LiveKit. So it's launching beta today and it's free until the rest of the year. So now I'll hand it off to Dylan, who's going to show you how it works.
All right, hello everyone. My name is Dylan. I'm a staff product designer here working on agent observability stuff. So I'm gonna walk you through the new UI. Under sessions, if we navigate over there, let's see if we can find that call Nasheed just did. So in the sessions list, if you open up a session, you'll still see your session analytics. This is all your room data. It's still here for you to review. But we also have this new tab called Agent Insights. So if I switch over to here, we now have a synchronized playback of the audio along with transcript, traces, and logs all paired with it that you can dive into. So from the top here, you'll notice this audio bar. We can play back the audio.
Hello. Welcome to Live. Hi there. How can I assist you with stock prices today?
Hi, what is the price of Apple?
So you could play back the call in real time and hear what the user was saying. You'll also notice that the transcript is synced to the timeline, so you can find and pinpoint when these things are happening. We also surface these inline notifications, so you can check out the tool call that was just fired. You can dig into the details of it. You can look at the transcript confidence, the latency for the assistant on the turns, and see all the different attributes for it there as well. Next, we can navigate to traces. And here you can see all of the spans that were performed through that session. We can open up a user turn, see when they were speaking, see when end of turn detection was fired. You can also open up the agent turns and look at the LLM nodes. So you can kind of see the overlap of things and the timing and what items you need to improve and iterate on. And then finally, if we switch over to the logs view, you can see all the logs that came down from that agent across the media room as well. You can filter through them. We can get rid of debug information here. We can see what this warning was, all in real time, all synced with this audio. And so to enable this for your agent, you'll head over into the settings. Under projects, you'll see this new agent observability tab. You'll switch this into enabled. And then from there, you'll run the agent SDK 1.3. And you can also control this at the agent level to surface your new agent insights. And so that is agent observability. And from here, I'll hand it back to Russ.
Of course, it's going to be me who can't get this thing on. So what do you think? Team cooked, right? Yesterday was my first day back from parental leave. And Nishad said to me that they've shipped more in the past month that I've been gone than the whole time I've been at the company. So, you know, I'd agree. I'm going to be out of a job soon. Thank you all for coming. All of this stuff that you saw is now live. So you can go, use it, play around with it. If you have any feedback, we'd love to hear it. We're going to continue to iterate on it. And yeah, I'm excited to chat with all of you afterward. And I think it's happy hour time now. Also want to thank folks on the live stream on the internet for joining as well. Appreciate it.